Welcome back, Bafundi, to our last segment. Now, in order to draw a pie chart, you need to make sure that your data is in percentages. If it is not, you need to convert it into percentages. In order to calculate the percentage of the variable, divide the variable amount by the total of that variable and multiply the answer by 100. That will give you the percentage value for that piece of data. If it is a simple percentage such as 50% or 25%, then it is easy to subdivide the circle. However, if the value is not a simple percentage, you will need to work out how many degrees of the 360 degrees making up the full circle this sector will occupy. Umzekelo, for example, 30% will occupy 108 degrees. How do you calculate this? Well, you'll divide 30 by 100 and multiply the answer by 360. You would then need to use a protractor to divide up the circle accurately into the different sectors. Draw the circle and the sectors in pencil. It is a good idea to color the different sectors of the circle and label or provide a key. Now, of course, the pie graph must have a heading like all your graphs. The next kind of graph we will focus on is called a histogram. A histogram looks similar to a bar graph, but the bars do touch each other. We draw a histogram to show quantitative data that can be grouped or ranked. Here's an example. Suppose you want to find out how many learners achieved between 90 and 100% for a test, or between 80 and 90%, or even between 70 and 80%, and so on and so on. The data on the x-axis is quantitative as the marks are numerical, but we can group the data into 10% groups. This is called ranking the data. We plot the data by using bars, but this time the bars are touching each other because the data is continuous. Histograms gives us a good picture of how data is distributed into groups. When drawing a histogram, these are the things you should keep in mind. The x and y axes should be drawn in the same way that you constructed them for a line graph and a bar graph, with the dependent variable on the y-axis and the independent variable on the x-axis. The y-axis will be labeled and scaled normally, but however, the x-axis needs to be divided into ranges to show the different groups of data. Label this axis carefully. Now plot the points on the graph by reading the x and y values. Do not link the points with a line, but draw bars of varying heights. The bars must touch each other because the independent variable is continuous but grouped into ranges. Like any graph, there must be headings that reflect both variables. So, what is wrong with this graph? This is a histogram. The ages of the mothers are ranked into categories. The bars representing the data should therefore touch because the groups representing the ages are continuous. Now, it is very important in science to be able to interpret the information depicted by the graph and to be able to describe the trend that you see. The trend refers to the pattern that emerges or the relationship between the variables. In graph A, we have what is called a direct relationship. What this means is the x value increases, so does the y value. In graph B, however, as the x value increases, the y value decreases. This is an indirect relationship. In graph C, as x increases, y remains the same. We call this a constant relationship. Another constant relationship could be illustrated with a vertical line on a graph. As the y value increases, the x remains constant. Now, are you able to describe the trend that is shown in this graph? As the pH increases, so enzyme activity increases in direct proportion. As pH increases further, the enzyme activity remains constant. Further increase in enzyme activity will bring about a decrease in enzyme activity as pH and enzyme activity enter an indirect relationship. Now, if you are able to get that right, you are well on your way in being able to expertly interpret graphically displayed data. So well done. That's it for today's lessons, Bafundi. I hope you've absorbed as much as you can on preparing and constructing graphs.